let me just do this first, trig integrals. So this integral, okay, minus x 1 plus x squared. The limit is not 0 to infinity, no. I want to use Gauss quadrature, okay, which is, in fact, you should try to use Gauss quadrature almost all the time. So the idea is 0 to infinity. So this can be written as 0 to infinity exponential minus x 1 plus x squared dx minus 0 to 1. Okay, now this can be done by Legard polynomial, Gauss-Legard, right? Of course, this function is infinite order polynomial, but still, if we choose n equal to 5, you will get pretty good answer. Okay, so and this integral, which one should I use? 0 to 1. It's a Gauss-Legendre. We should use Gauss-Legendre. So we did Gauss-Legendre from minus 1 to 1. Right? So any function fx dx. Now, if I want to change the limit 0 to 1, I need the change of variable. So I want to rewrite this as some new variable. So fx prime dx prime 0 to 1. So for this, what do I need to do? So I write this as x prime equal to ax plus b. Okay. Now for x, so I want when x prime is 0, x is minus 1. When x prime is 1, then x is 1. So a1 plus b. Okay. Now from this I can solve, right? What should be a and b? Okay. So I will not do this algebra, but you just make a change of variable. And the formula is of course there in the notes, but you can just do a change of variable. And so, well, I mean, so we want to, well, I mean, there will be some prefactor. Huh? So let me just do this part. So a equal to b. Then here, so a is half and b is half. Okay. So if I do this, is a minus half or no? No. So x prime is equal to a plus a half x by 2 plus half. So when x is 1, of course, I get 1. When x is minus 1, I get 0. Okay. So this is my formula. So I think I need to get rid of this. So I make a change of variable. So I want, okay, so I want 0 to 1. That's what I got, 0 to 1 fx dx. This is what I got, right? Now I make a change of variable, x prime. So I replace, so I had to write, okay, anyway, this is algebra, okay? So you replace dx by dx prime. So what do you do? X prime equal x plus half. So what is x? X is 2x prime minus 1, right? So dx prime will be 2 dx prime. Now fx we replace it by fx prime. I just need a change of variable. Okay, so just replace x by x prime here, and we can do the integral, and this doable. Is that clear? So a change of variable will do the trick for the second one, and I just did some addition subtraction. Now, so this is what I wrote. Now this integral. Now this integral is 0 to pi by 2, so it is like finite limits both sides. But this integral still has a problem. Okay, what's the problem with this integral? This function, when x tends to 0, what happens to this? So cos x becomes 1, so it goes as 1 by x to 1/3. And if you plot this function, it is going to be going to infinity. It's just going like that near x. So if I mean I have to really use small tiny h, but this will be a problem. I mean the numerical integration is a problem for this. So we need to massage it. We need to make some changes. So a simple idea is to use this stuff. So we subtract 1 in the numerator. So cos x minus 1 and add 1. Okay. So cos x minus 1 by x 1/3. So now this integral. What about this integral now? Is it singular or non-singular? So cos x minus 1 will be x squared, no? X squared by factorial 2 divided by x 1/3. Now this is x 5/2. What is it? Not 5/2. 5/3. So this is now finite. Is in fact starts from 0. So this integral now is fine with x near x equal to 0, no problem. Okay. What about this part? This integral is analytically doable. We don't need to do a computer, right? I mean, you don't need a computer for this. It's x minus 1/3, so x 2/3 by 2/3, 0 to 5. Okay, this is a finite value, a finite answer. Okay, so we can do this by hand. So this is one trick to solve this problem. But you need to apply logic, or you need to apply some, not logic, intuition to get. Now we can do the same integral by, okay, we can do by parts. So we can take this as first function, second function. So yeah, so by parts you get integral of this 3 by 2 x 3. No, first function is cos x. This is cos x. Integral of this 0 to pi by 2. Then derivative of the first function, which is sin x. Minus minus becomes plus, and this integral. Okay. So now this integral is, this integral is not singular anymore. Okay, because x 2/3 is finite. In fact, it goes to 0 near x equal to 0. Okay, so that's another trick. Okay, so these are some tricks. Depends on the situation. You have to apply intuition. Now, one book I recommend is it's a mathematical physics book, Matthews and Walker. It's a very nice book, which is a lot of tricks. It's math physics. To multi-dimensional integrals. So 2D integral. So we have the domain, which is x goes from 0 to a to b, and y is, for given x, y is also a function. Okay, so this is my domain, and I want to do the integral, this one. So fxy, this is my function integrand, but x goes from a to b, but y goes from 0 to gx. Okay, so this is my y integral. Okay, now what do I do? So you can use Newton codes or Gauss quadrature, no problem. But we are doing 2 steps. So first step is we can do the x part. So a to b dx, and this is some function of x, right? This is some function of x. So okay, we don't know what this function is, but I discretize along x. So wi and value of the function at this function at those xi's. Okay, so I discretize with Newton codes, Gauss quadrature, and I compute this. But this one requires this integral, y integral. Now I replace this y integral by discretization along y direction, in that direction. So wij fxi yj. Now this will, so we need this. Okay, so weights wi and wij. But I mean, okay. So this is along y direction. Okay, so this is I'm just writing wij because it's function of x. But use 3 points and use a Gauss quadrature or Newton codes. So, but this is not just wj. It depends on I. Okay. So, anyways, you can do it yourself, or you can use Python's function called quad. So quad is a nice function. We don't need to write. In fact, neither Newton codes nor Gauss quadrature. It just use quad. So so you have to give lower limit and upper limit and the function. Okay. So the idea is from psi pi call quad, and so quad now function and limits. Okay. So these are three arguments: lower limit, upper limit. Now function, I'm using lambda function. Okay. Remember, lambda function was a nameless function. Okay. So if I don't do it, then I have to write f, and I have to write f of x return x. Okay. I avoid this extra two lines. I just insert it here by nameless function, anonymous function, lambda x. Okay. Now it's very useful. I mean, in fact, this is better way to write than writing three lines, because in one line I understand what I'm trying to do. Well, I understand what somebody else is trying to do, because normally you need to read codes. Okay. Now we can also do for this function 0 to infinity. Infinity is a variable in Python. So I can just write it INF, infinity. Okay. It gives integral and also the error. Okay. So second argument is the error. Now 2D integrals we can also do with quad, but this is called double quad. Double quad. Now remember, so my function is xy, which is a lambda function. I defined by lambda function. Lambda function. So it has two arguments. Arguments are two, but it returns only one function. Lambda function has one condition, that should return only one answer. So x star y is the answer, and we got this stuff. And lower limit, upper limit, there are two of them. For x, lower limit is 0, 1. For y, lower limit is 0. Upper limit is x. So this again is a lambda function. Lambda x. Okay, so very useful, and you get the answer. For 3D, we can do something similar, x, y, z, and there are 6 limits. 0, 1, then we have 0x, then we have 0x plus y. So 0 and x plus y. Okay. Now this is with 3D integral. You can use Simpson and trapezoid as well. So scipy dot integrate, also import, you can import Simpsons. Okay, and so this is my y's, so yi's, and we assume that x are spaced by 1 unit. You don't need the origin. I mean, you don't need the origin for integral. We just need dx, right? So dx is okay. So Simpson rule, if you apply with the 3 points, you get answer is 4. We can also define what is x. So right now I give only value of y's, 3 points. But we say, well, I want to give where are these functions evaluated? They're 0.1, 0.2, and 0.25. Okay. Then you have to give both arguments, x and y. Okay. Now, this turns out that h is not uniform for this problem. H is 0.1 and is 0.05 here. But Newton codes will work with h non-zero, h non-uniform. Okay. It's just more work, more complex formulas, which I didn't derive it, but it can be done. Okay, so that's about it for integration.